guys, welcome back to a new video on Python for beginners. In this one we'll be looking at the main data types in Python and how we could use those to output different values. Before we get into that, let's recap what we did last time. In the last episode we created a variable to store information like let's create a variable called speed, and then we assign it to the speed of light, which would be that. The reason I put an underscore here is just for the human to be able to understand what number is, because without it, you wouldn't know this would be 300 million. So it acts like a comma. You can remove it or keep it like that. I'm just gonna keep it like that just so it's easy to see. So why using variable is good is that now we're giving some information, and it's easier to call them rather than typing out 300 million. So when we're calling them, we can just, instead of every time you want to call that value like that, we just run this. Instead of just calling that every time here and get 300 million, you could just write speed and then Python. So I figured out how you could write in the terminal. So you gotta write Python and then the app name hello.py inside the Python terminal, which you can get from running the thing. So hello py. Never mind, you still gotta run the thing from here then, which is still like this, same thing but way easier to remember. Let me just clear this. Okay, now let's get into the going data types, but before that, if this video helps you out, make sure to subscribe, as it would help me out. Alright, so there are 4 main data types. First one being string, second one being integers, and third one being floats, and the last one being Boolean. There's more data types, but these are the 4 main data types and the ones you'll be using the most right now. So in some other languages there could be more or less data types. For example, the language C also has a data type called char, which only takes one single character, where char is small for character, short for character. So yeah, but Python doesn't have char. One single character would be known as a string. Also, last video we touched on strings a bit, but let's go more in depth. So I shall keep that here for now. Alright, so let's declare a variable called name and another one called gender. We'll give name, let's just say Smith, and then gender male. You can capitalize this if you want or not, you can capitalize that. And then now these two variables are holding a string, and how Python knows this is a string is because of these two double quotes. And for some text editors, a string will be highlighted. For me it will be highlighted brown, for you might be different color. If you use the same text editor with the same themes, it will be highlighted brown. And a string can also be made up of single apostrophes. So these are being apostrophes, and a string can't be made up of both apostrophes and double quotes in some cases. So let's just say let's just put back this back to Smith. We'll print. So let's just use single apostrophes for this example. So we do this. In grammar wise this makes sense, but in Python, how Python seeing this, it sees this first apostrophe and then sees the second apostrophe, and then Python thinks this is the end of the string, so this is all the what's inside the string. But for us, we know this should be there for grammar's sake, and that is actually the end of the string. So what we can do to fix this issue is first we can use a backslash, and then Python will now know this is an actual string, and this is the actual end of the string. But this looks a bit messy, and especially when you have a big a long string. So what you could do is get rid of this and replace these apostrophes for double quotes, and then that makes sense for Python too, since there is no double quotes in the middle. And so it won't make sense just to put a double quote between Smiths. So that's important to know. I'll show you what error it'll throw if you do it like this. Run this, and it says invalid syntax, line 9. You can see line 9. It's pointing at this S. Well, it's pointing at this S because S is not a string. S is not a keyword either. S is just nothing that Python can understand. Python can understand only string, integers, floats, and Boolean, and some keywords like print or more other ones. And how we make Python understand S is we create a variable called S, and then we set that to anything like Jack something. So yeah, but get this back to normal. Actually, we can just delete this line. So what I wanted to show you is the string is some concatenation. So when we print, right, we could print name, and obviously it'll come up with Smith, and we print gender, it'll come up with male. But how do we print name and gender? Because if we do this, it'll throw us an error, invalid syntax again, because you're not really telling Python what to do here, you're just putting a variable after a variable. So let's just see how we could put a name, this variable name, in a string. So this is not a variable, obviously, and it's just a string. So if you wanted to put name right after this string name, so if you want to put Smith after name, what we do is we get the plus operator, and then we write name. Let's clear this. This will work. Name and that being Smith. But the problem with this is, you see there's no spacing here. How we can fix that is just add our own spacing, and then that's fixed. Now we have name and Smith, but there's a better way to do it. If you don't want to create spacing, we can just add a comma, and this is another way to concatenate a string, a string with a variable. So we run this, and then it does the same thing as above, but we don't need to add any extra spaces. Alright, so what I want to, this is another comment again. What I want to print is name Smith, and then gender being male. So what I want you to do is try to figure out how you could do this. I'll give you 10 seconds how we can make it where it outputs this from the variable gender and output in this single print. I'll come back in 10 seconds. Right, hopefully you've got the answer. So what we do is we add another comma. We can do a plus operator, but it's a bit more messy if you do plus or a comma, and then we add another string and we denote the string with a double quote, and we write gender, and then we do gender. Pretty weird variable names and strings, but it makes sense for Python and it'll make it work for it. So let's clear this and oh, alright, that was pretty weird. So now we've got what we wanted to output, and hopefully you got this right. But if you haven't, don't worry. It's you'll get used to this the more you use it. So that string concatenation, we'll go more in detail in that in a different video, but we need to move on to these three data types. Let's delete this. We've completed strings now. Now let's go to integers. So integers in the math area or in the real world meaning is a whole number that cannot be negative, I'm pretty sure. But in Python, an integer can be a negative number, and we could just do age. So let's get Smith, name back in, name being Smith, and then let's get age in, and age being somewhere like, let's say 17. So you can see this is different to the string. First thing first, there's no quotes around it or apostrophes, and second is green. Sometimes they want to show green. Let me show you what happens when we just put a quote around it. You can see there's no error coming up, and if we print this, that's great. It'll work. So let's just do that. So obviously print 17, and we have apostrophes here, but for age we don't really want to do that, because let's just say we wanted to know how much days that person has lived for, roughly. So what we would do is times it by 365, but that doesn't make sense. It'll work, but for Python it'll output something way different. I'll explain. So let's run this, and then it outputs this, which is not what I should have outputted. Well, let's explain what's happening. So what's happening is we've assigned this variable age the string 17, and what we're telling Python to do, it times this string 17 by 365 times. So what we're doing is we are doing that 365 times. Instead we should have got whatever was 17 times 365, and how we get that number is not making these strings. And let's clear this, run this, and then there you are. That's more of that was the number we were looking for. Just wanted to show you the difference between putting a number in the string and putting a number in making a number an actual integer. But for sometimes you do want some numbers into a string, so let's just say phone number. That being, we don't want it to be like for random numbers. That should be some numbers, because some numbers could have sometimes phone numbers could have a dash between them. So what's better is just putting in a string, and we know we're not gonna do any mathematic operation with these phone numbers, so it's alright keeping it as a string. There's more math operators you can do. So there's times. So should I multiply? No, cover. Multiply. That's multiplying it. Divide. That's dividing it, and subtracting it, and obviously adding is just a plus sign. That being a dash, by the way. So we'll go more over data types, not data types, more over operations in a different, probably in the next episode, or we might go over concatenation in the next episode. But that's basically integers for you. Now we've done integers, let's go into float. Float is pretty complex for Python to understand sometimes. When I mean for that, I mean what I mean there is Python can't hold really small float numbers. I'll explain. So basically, what a float is a decimal number. So a good decimal number might be let's just say miles ran. So you might run 4.2 miles, and that's a float number right there. A integer would be 4 miles, but if you want to be specific, you run 4.2 miles, and we print miles run, we get 4.2. But what would happen if we print let's just do this. I'm pretty sure this won't work. Let me check. Yeah. Actually, hold up. Just adding some random numbers here. Alright. So why Python is doing this is because you can see it's truncating from here onwards. Why it's doing this is because for some machines, you know, some machines run on 64 bits, so that means they can go to 1, then 2, then 4, then 8, then 16, all to 64. No, like 64 times. So that's 1, 2, 3, 4, 5 times. You can do that 64 times. And for decimals, it'd be 1.5, 1/4, 1/8, and 1/16. And that would go on for 64 times each way. Some does 32 bits. And why Python truncates this from here is because the machine doesn't have enough memory to store this variable fully, so it truncates it. So let's just add a number here. It's carrying on, but since it's let's just do I carry on this. See, it truncates it from here. So when you're working with Python, you gotta keep in mind very specific, very small numbers won't be displayed, but for in the other way around, really big numbers will be displayed because Python has that covered. Python knows how to display those big numbers, just like those. Because this is also 64 bits, but it's easier to display a non-decimal integer than a decimal. Let's go back to float. So we can do some math operation with floats by like adding 4.2 by 0.8, and then you run this, and then it goes to 5. Remember, since it's a float, it's still a float value. It'll end with a 5.8, it'll end with a 0.0. So that's pretty much a float. Now let's go into Boolean. Alright, so a Boolean is either one of two values. It's either yes or no, or a true or false. Python does it with a true or false, but we could just say as yes or no because this data type is so simple. So let's just say make a variable called has eaten, and that is equal to true. So it just checks if someone has eaten like the breakfast or something, and if they have, the output true. So let's print has eaten, run it, and it shows true. And this is really important when we go to if and else statements. I'll just quickly show what if and else statement is, but I won't go much details. So let's just say if let's get has eaten again. Has eaten. If has eaten true equal true, print we'll put that there for now. Else print eat soon, and then don't eat soon. It's pretty weird this, but like it helps you understand a bit. So we know this is true because it's true here. So this if is testing if this is true, and if it is true, print this out. If it's not true, print this out. So it should print that out. Don't eat soon. Let's make this to false. Print that out and eat soon. Alright, so that's all the data types covered, but I want to show you a bit more about important modules in for data parts and what data types, what modules are, and what methods are. Is basically some code that someone wrote, and then you can use it. It's hard to explain. I'll just show you. So let's say we have age again, and that's a age 17 again, and we print age. So age is 17, and then let's just say we just want to change this age into a float. But how do we do this? we could, before age, we could write float and then an open bracket and a closed bracket, just like how we did it for print. Because print is a method, well actually it's a function, float is a function, and age is a variable. These functions have been written by someone else, well by Python to be more specific. And now let's run this. Now is a float number. Let's just say we want to make this into a string. We can't do string because Python names it somewhere else, which is str. Str is short for string. So we run this, and now you see no difference. So now let's just times it by 3, and then you see that 70, 70, 17. Let's just get rid of the str, run it, and then it's 51. So we can also change it to, we can change a string into a integer. So we do integer, and then we do 20, no, we do string, and we can test that by times it by 3, and there you are. Another important thing is, if you don't know what data types is, we can do, so print, so let's just do again has no, miles run would be 4.2 again. Let's just do that. And if you don't know what data type you're handling with here, you can just do type, which is another function, and then you do miles run. This one output 4.2 or anything. Well, we will output something, but we won't output 4.2, but instead we will output this gibberish a bit. So what you're looking at is this part, and this tells us the float. You don't need to worry about classes right now. Those are really complex. We can come back to this in a very far episode. So float, we know this is a float because it has a decimal. Well, let's see this. Let's say if we didn't know if this was a float. Well, it's a float as it says here. Let's say this. It's in small for integer, short for integer. I mean, and let's say this string. We can also do Boolean, false, and that being a bool. Well, that's about it. That's all for data types. I hope you find this video helpful, and if you have, make sure to subscribe. It'll help me out a lot. Next video we will be going over concatenation, unless it's data types. I mean, unless it's operations. Thanks for watching.